Hello everyone, good evening. So we have Brazil here, Carol, my diaries. Yes, I hope I'm visible and audible to everyone out there. Yes? Hello Sonu Singh, hi Shivansh, Arpit Kumar, 8P, hello. Yes. Riddhi Jain. Alright, so I hope you all can hear me and see me. Yes? Quickly give me thumbs up and smileys. Hello Adhira Deshmukh, Puneet Kaur, Veer. Alright. Yes. Alright, Carol says you're audible and visible. Alright, so there is no glitch at all. So we can start. My name is Khushbu and a very, very warm welcome to yet another wonderful session. So today's session is basically the concept session 1 on number system. So we have already done a session on number system, but that was a bridge session followed by a quiz, right? Alright, so what we will do today is, we'll be covering a few concepts of this chapter. Yes, so let me just quickly walk you through the flow of the session first. So today we will start off with family of numbers followed by fractions, then we'll talk about rational numbers, irrational numbers, and finally we will end this session by discussing about the decimal expansion. So all these topics will be covered in this session. Yes. Wow, happy birthday Fuzel. This is not the revision session, this is the very first concept session, Nivya. So we have just started with we are going to start with the new concepts today that you have in this chapter. Alright. So before I start, please subscribe the channel so that you do not miss any new updates from us. You will keep getting notifications about the upcoming sessions. Alright. So let's get started. So I want you to meet someone. So this is Rahul and Simran. So Rahul has recently come in grade 9th. And he asked Simran that, do you know how many numbers are there in maths actually? And Simran doesn't know, but she's a curious kid. She wants to know about it. So Rahul is a smart case. He says, let me show you. So let's take a quick look at the family of numbers. So we all know what natural numbers are, right? It starts from 1 and extends up to infinity. 1, 2, 3, 4, 5, 6 and so on. Yes? Alright, and if I add 0 to this family of natural numbers, what do we get? We get whole numbers. So whole numbers start from 0 and they extend up to infinity. 0, 1, 2, 3, 4, 5, 6. See, when we are learning this chapter number system, it's very important that we have a thorough understanding about the family of numbers, because this is a very basic thing. This is the fundamentals of this chapter, I would say, and many times your fundamentals only are not clear. So, you have a hard time understanding the new concepts then. Yes, international shooting, sports, yes. Oh, thank you, Fuzel. Alright. So, if I move towards the left of the number line, we get negative numbers like -1, -2, so on like this till minus infinity. So all this comprises of integers. So basically integers include these negative numbers, this 0 as well as these positive numbers. So integers are including whole numbers, I can say, as well as natural numbers, as well as these negative numbers over here, right? This is easy to understand. I'm sure it is clear to everyone. Yes, what integers are now. So now that you have understood this, let's try out a question to check your understanding. So here we go. Which of the following is an integer but not a whole number? You can see 4 options on the screen. I'm giving you 30 seconds to answer this. So quickly tell me, which of these is an integer but not a whole number? Crystal clear to everyone? Great. Thank you, Goma Joshi. Natural numbers 1 to infinity. Zarina. Yes, absolutely right, Zarina. So I can see everyone is saying, Hershey says D, Alfina, Anju, D. Everyone is saying it's -1, right? Prasansha, Devansh, Nivya. Okay, time is up and let's check the answer. Yes, you're absolutely right. It's -1. So this concept is clear to everyone, right? I don't think I need to give any explanation on this, right? Quickly give me thumbs up. This is clear because everybody has given the right answer, I can see. All right. Rashmi, Shivansh, Pushpa Saha, Goma Joshi. So you will be, for you, it's just, it's nothing, right? So I can see thumbs up and smileys. All right, this is clear to everyone. Let's move ahead. Let's see what those two kids are doing now. Oh, they're ordering a pizza. Wow. That's a good idea, right? And he says, wow, because they have got the pizza, they ordered pizza and this has gotten, wow, such a quick service it is, isn't it? But the girl says, there are no slices, because if they want to eat it, they will have to cut it into slices, right? So, he's saying, wait, let's see this. So, let's take a look at this. So, take a look at this yummy pizza. The pizza is placed between 0 and 1, right? So, if I cut the pizza into exactly 2 equal pieces, you can see that 1 by 2, it is placed between 0 and 1. And if I cut this half of the slice into further half, we get 1 by 4, which is placed between 0 and 1 by 2, right? Now, so we saw these 1 by 2 and 1 by 4, these different kinds of numbers, and we know these are called fractions. Till now, we know this thing. Same Rashmi, I also feel like eating it. So the boy is saying, did you see what just happened in the clip? Girl says, Simran says, yes, our pizza got divided into fractions. So we are all aware of this term fractions, right? But he says, yes, but there is a specific term that we use for such numbers. And Simran doesn't know it. She says, I don't know this. So what is it called actually? He says, let me show you. So the specific term over here is rational numbers. So these fractions that you saw there, those are nothing but these are rational numbers. So what are rational numbers actually? So numbers which can be written in the P by Q form, right? P by Q form, by P by Q form we mean something in the numerator and something in the denominator, right? Where P and Q are integers. This is important. P and Q have to be integers. So what all do we have in integers? We have -3, -2, -6, 1, 0, numbers like that. But Q should not be equal to 0. 0 can never come in the denominator, right? That's the restriction. So remember this thing. Always P and Q have to be integers. So these are nothing but these are the rational numbers. Alright. So if I talk about rational numbers, many times students have this confusion. When they see the numbers, they get confused. I tell you something. Like in fractions, we have -1 by 3, -1 by 2, 1 by 2, 1 by 3, 1 by 4, numbers like this. And we can see in the numerator as well in the denominator, both of them are integers. Like if you talk about -1 by 3, -1 and 3 are nothing but these are integers. If you talk about 1 and 4, these are nothing but integers. And you can see that denominator is not 0. Yes, audio is not clear. Why is it so? I hope it's working fine for others. Yes? Quickly give me thumbs up in the comment section if it is working fine for all of you. Shivansh, I'll answer to your question. What about A, B, C, D? It's clear, yes? Okay. Alright. So, yes, so you were saying what about A, B, C, D? What is A, B, C, D? Basically, what we are doing here is, I'm saying that, I said that rational numbers can be represented in this form, right? Where these two have to be integers. So I'm just telling you, if you check the numerator and denominator in each one of them, they have to be integers. Good thing. Yes, I'll come to this point. And integers, they are like -1, -2, -3, 0, 1, 2, 3. So both of these are nothing but these are rational numbers. So rational number is comprising both of them. It has got these integers as well. It has got these fractions as well. Right? But you see that in integers we do not have decimals. No decimals here, no fractions here. Here we have got decimals. Many times students have this confusion. Yes? Thank you, Ghansham. Alright, so I hope this is clear to everyone. Now we have a clear understanding in our minds that what all is included in the rational numbers. Yes? And what all we can include in the integers. Arshi will be covering this as well, don't worry. Yes. It's not that, Zarina, why we have to take P and Q in fraction only. It's not like that. I can represent this by M by N also, A by B also. It depends on the books, right? But if I talk about your NCRTs, P by Q is mentioned. Doesn't matter. P and Q are actually representing integers only. Yes. This is clear to everyone. I hope no one has confusion in this now. Quickly, thumbs up, smileys, hearts. Yes. Vijayja says yes. Guru Gamer, Yes, that's okay, Anushka. Prashansa says clear. We will not say all the number system, Pushpa. We will come to this point. Thumbs up, smileys, clear. Great, awesome. So since we are talking about rational numbers, so what about the equivalent rational numbers? Yeah. So let's take a look. So two rational numbers are said to be equivalent if their lowest forms are the same. That means they have the same value but can be represented in different forms. Let's take a look at this. What do we mean by lowest form? So 1 by 2, 2 by 4. They are equivalent rational numbers, right? They are written in a different forms, but they both mean the same, right? Because if I cancel this out, again I get 1 by 2. 3 by 6 is also same thing, right? 4 by 8 is also same thing. 16 by 32 is also same thing, right? These are equivalent rational numbers. So this is another, I would say this is a part of rational numbers, but equivalent means when they are representing the same form, but written in a different way. Yes, Aharshi. So I hope this is clear to everyone. Yes? So now that we have this clarity, let's try out a question. So here we go. Which of the following is the equivalent rational number of 16 by 28? I'm giving you 30 seconds to answer this question. Let's start the timer. So out of these 4 options, you need to check which one is the correct. Yes, Shivansh, that's right. You can pick more examples like this. So Mesh is the first one to reply. 4 by 7 is the answer. Vijay is saying difference between fraction and rational number. So when I am saying fraction, exactly, right? So you can write any numbers like this, 3 by 4 minus 3 by 4. But when I'm using a specific term here for a rational number, so for fractions, as I said, we use a specific term. In rational numbers, we are including everything, your integers, your, I mean, all your integers, whole number, natural number, like everything. Yes, so specific term is there. So 4 by 7, yes, that's the answer. Everyone is saying it's A. So we all know that 16 by 28, once I reduce this, I'll get 4 by 7, right? That's the final answer. But if you look at these two numbers, minus 4 by 12 and 4 by minus 12, right? So do you think that in these two numbers are same? These two kids are also confused in this. So he's asking, do you think in the previous question, these two numbers minus 4 by 12 and 4 by minus 12 are same? The girl says, yes, because both are equal to minus 4 by 12, right? Because when I talk about the standard form of a rational number, so now that we are talking about this thing, so this just came to my mind. When we talk about the standard form of a rational number, what does the standard form say? Standard form says that there should be nothing common between the P and Q, right? Nothing common between B and Q means nothing common between the numerator and denominator, and denominator should not be negative, right? Q shouldn't be negative. Q shouldn't be negative, right? So here when I am talking about, so minus 4 by 12, 4 by minus 12 can be written as minus something like this, 4 by 12. Alright, so both of these are representing the same thing. Right, Rishit, absolutely. So whenever if you are asked, let's say if you are asked to write the rational number in the standard form, if I have to write this minus 4 by 12, let's say this one in the standard form, I'll reduce it, that would be 1 by 3, I'll put the minus sign here, or you can put the minus sign here as well, like here in the middle like this. Yes? Clear? Divansh, minus 4 by 7, 4 by minus 7, you are right, they mean the same, but when you talk about the standard form, right, so we write in the numerator, or you can write here like this. I hope this is clear to everyone. Yes, quickly, thumbs up, smileys. Ishika says, okay, Prashansa, I can see hearts. Yes. All right. Yes, Akansha. Yes, I'll come to this point. All right, all right. So now, the question that you asked, this kid has the same question. What if the numerator and denominator both have the same sign, right? Both have the same sign. Let's say they both are positive, or either they both are negative. Then that rational number would be a positive rational number. Let's take an example, the same example that you took. If we have minus 4 by minus 7, right? So definitely both are negative. So negative, negative, I explained to you in the previous session also, they will cancel out each other. So final rational number is going to be positive. Or if it is like this, so anyways it is positive. Yes? I hope this is clear. Yes, negative and negative gives positive. Right, Aharshi? Both gets cancelled out. Right. Yes, Rishit. Yes, minus minus will cancel out. So that's a positive rational number. All right, all right, all right. Now, what if both have different signs? Then what will happen? Let's say both have different signs. This is positive, this is negative. So in that case, we will call this rational number a negative rational number. Or if it is written like this, again it is a negative rational number, right? If they have different signs. If we have both numerator and denominator negative, then we will have, yes, because negative negative cancel out each other. One negative cancels out the other one. So I hope this topic is clear to everyone, right? All right, now let's try out a question that how much you have understood actually. So is minus 5 by minus 7 a positive or a negative rational number? Quickly, you have 30 seconds to answer this. Positive or negative? I don't think Subrata and Akansha have answered to this question. Everybody is saying it's A. Amrut, Akansha, Kumari Sohani, Ojas Tyagi, Shivansh Shukla, Subrata, Anchal, Anushka. Everybody is saying it's positive, it's A. Okay. So what is the right answer? Okay, time is up and the correct answer is yes, it's A, positive, because we know that now negative negative will cancel out each other. It's going to be positive. Right. So this is clear to everyone, right? All right, let's move ahead. Now let's see what those kids are doing. So she says, hey, I have a doubt. Now that smart boy, he says, okay, ask me. She says, what about the numbers like pi? Because we all have been using pi for like, I think you start using pi since you from grade 6, right? So, but we never try to understand what kind of a number is it actually. But this girl Simran is so curious. So this boy is saying it's a rational number. It's an irrational number. Now she doesn't know what irrational numbers are. So he says they are also a part of the family of numbers. Family of numbers. So can you explain them? He says yes. Let's see this. So let's understand now what irrational numbers are. So numbers which cannot be written in the p by q form, where p and q are integers and q not equal to 0, they are irrational numbers. So basically, rational numbers could be written in p by q form, and this is same. P and q are integers, q not equal to 0, but we cannot represent irrational numbers in p by q form. Let's take an example to understand this. Like we have root 2. So if I solve root 2, what do I get? The decimal expansion is 1.4142135623730 and so on. Oh my god, it's not ending, it's not terminating. Yes? So that means the decimal expansion is endless. Yes, Ishika, right, they cannot be expressed. Okay. I'd like to answer this question. All fractions can be rational, but all rational numbers cannot be fraction. Yes, that's right. All fractions, you can call them rational numbers, right? Yes. Because the value of pi. So yes, we will answer to this question. Like root 3 is 1.7320508077. You can see that it's not ending, and you can see numbers every time they are different numbers. There is no pattern over here. So take a look here. So why do we actually call pi an irrational number? Look at this, 3.14. This number is not ending. Yes, this is endless. This is not terminating, right? So if I talk about the real value of pi, so we generally use the approximate value, right? Generally 3.14 22 by 7 while solving the questions. Yes? Right. So while solving the questions, we are using numbers, we just use it like this. But we can see that this number is not ending, and there is no pattern even in the digits which are after the decimal point. Right, Anchal? That's the approximate value. So this is not terminating because it is not ending and not repeating also. Thank you, Anushka. Alright, so we have understood that pi is an irrational number. Now let me give you a very small trick, right? What if you are asked to find out an irrational number between two positive numbers? So this trick is applicable where, let's say we have two positive numbers a and b. And if ab is not a perfect square, that means you are going to multiply those two numbers. If it is not a perfect square, then square root of AB would be an irrational number that would lie between these two positive numbers. So you can use this trick in the questions. So I hope this is clear to everyone. Yes. Arshi, your entire message is not visible to me. So whenever we are talking about an irrational number, you have to find out, but you need to keep that in mind. The product of those numbers should not be a perfect square. Then you can apply it, right? Alright, let's try out a question based on this trick. So which of the following is an irrational number between 5 and 10? You can see 4 options over here. Quickly tell me, which one of them could be an irrational number between these two numbers? One more time. Okay, so let me just explain it to you. What we did that. So here these are two positive numbers. I'm using the trick that we just learned. These are two positive numbers. Whomsoever is saying it's A, that's right. Okay, I'll tell you why B can't be the answer. See, these are two positive numbers, 5 and 10. Let's multiply them. Between 5 and 10 on the number line, we have to find out an irrational number. So the multiplication I get 50. 50 is not a perfect square. Non-perfect square, right? You know what perfect square is. Like 16, its square root is 4. Like 4, its square root is 2. Like 25, its square root is 5. So 50 is not a perfect square number. So when you come across such numbers, all you need to do is, between these two numbers, its perfect square would be square root of 50. Right? And if you want to take a look at the general form, so what we did was, between two positive numbers like A and B over here, and I checked, if I see that AB is not a perfect square, then irrational number between them would be square root of AB. Now I hope this is clear to everyone. Yes, Aharshi. So I explained it for the ones who could not understand this. I hope, Shivansh, this is clear now. Yes. Thank you, Prashansa. Yes, Aharshi. So these are perfect square numbers that you are writing. So if you do not get a perfect square number, then you can use it. Yes. Alright. So this is clear to everyone, right? Alright, so here we saw that how to write the irrational number between any two positive numbers, right? So when the multiplication of those numbers is not a perfect square. Now this girl has another question, that how do we differentiate between the different decimal numbers? Like we saw numbers like pi, it's never ending. There is no pattern also. So there may be other numbers like pi also, right? So how do we differentiate? Because different numbers will have different decimal expansions. So how do we differentiate that? So he says for that you will need to see their decimal expansions. Now she doesn't know what decimal expansion is. So let's see that. So when we talk about decimal expansion, so there are different kinds of decimal expansion. First is a terminating one. Terminating means, as the name suggests, that means it will end. That means the remainder will become 0 after a finite number of steps. That when we are dividing something, right, when you get the remainder 0, your division ends there, right? That is basically a terminating decimal expansion. Then comes the non-terminating one, where remainder never becomes 0. So this is endless. You keep dividing, keep dividing, keep dividing. Yes? Okay. Talking about the recurring one. As the name suggests, repeating. Recurring means repeating, right? It will reoccur. So decimal numbers that keep on repeating the same value after the decimal point. Let's say after the decimal point you're getting 1.252525, so on. Same value is repeating. They have recurring decimal expansion, right? Then the fourth one we have here, non-recurring. That means non-repeating. So decimal numbers that do not repeat the same value after the decimal point. Let's say 1.37243765. So you can see that after the decimal point, the values, the digits are not repeating, right? So this has a non-recurring, non-repeating decimal expansion. So I hope decimal expansions are clear to everyone. Yes? Quickly give me thumbs up. Thumbs up and smileys. Some cute emojis in the comment section if this is clear to you. Yes, AP Vanathi, yes. Yes. Real video, no. No means what? You have a doubt or there is no doubt. Arjun Das is giving thumbs up. Yes. AP Vanathe. Ruchi. Yes, Saharshi. Clear. No doubt still here. Alright. So let's try out a question now, right? So we will understand that whether we have understood the topic or not. So classify the following decimal expansions as either terminating or recurring. So you can see 4 numbers over here. So let's try out the first one. What we can see here is it's 1.568972. That's all. There is no dot 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 after that. That means this is the final answer. So that means the remainder in that case would be 0. That's why we have the final answer here. So it will have a terminating decimal expansion, right? Terminating. Zarina, please refresh the screen once. Alright, coming to the next one, 1.935935. Every time 935 is repeating, there is a pattern, right? So that would be what? It will have a recurring decimal expansion, right? It is repeating every time. Okay. Then we have 1.21212121. Again, it is repeating every time. Yes? Yes, recurring. Alright, then 1.2655. No dot dot after that. It ends here, that means. So this is terminating. Yes. Real video, I hope your doubt is clear now, because now we have used the examples. It becomes easier to understand when you apply those concepts in the questions. When you pick up examples to understand that. Yes, everybody is right. I hope no doubt still here. Yes? Yes, Shifa Ahmed. Both A and B, C can, ma'am, but both B and C are also non-terminating. Yes, that's right. They are, if you want, because question says terminating or recurring. Yes, you're right. It's non-terminating, recurring. You can, let's say in the paper, if you have, if question asks that what kind of decimal expansion is that, you can just write the whole thing. I will talk about that. So this is, see, these two examples are non-terminating also. These are non-terminating, but recurring. Yes, non-terminating, both B and C are non-terminating but recurring. Yes. Right, Anushka. Absolutely, yes. Clear? Okay, great. Let's move ahead. So now we will talk about these decimal expansions in detail. So decimal expansion of rational numbers, when we are talking about of rational numbers. See, in today's session we talked about rational numbers as well as irrational numbers. Right now I am talking about rational numbers. Don't get confused. So if you talk about the decimal expansion of rational numbers, they will always be terminating. The remainder will become 0 after a finite number of steps. Like if I give you 2.5 and I ask you what kind, whether it is rational or irrational, you would straight away say it is rational. Reason being, it has a terminating decimal expansion, right? Just by looking at the decimal expansion, you can tell it, right? Alright, so another thing, if it has a non-terminating but recurring decimal expansion, that means remainder will never become 0. But you can see that after the decimal point, the digits are repeating. Same digits are repeating. So those numbers also are called rational numbers. So just by looking at the decimal expansion, we can categorize them rational or irrational, right? If it has a terminating decimal expansion or if it has a non-terminating recurring decimal expansion, we will call them rational numbers. Non-terminating, repeating. Right, Rashmi. So that would be rational. I'm not talking about irrational numbers right now. Thank you, Harshi. I hope no doubt still here. Everyone has clarity now? Yes? That what kind of decimal expansion rational numbers have? Yes, quickly give me thumbs up, smileys, or whatever emojis you like. Yes. Prashansa says clear. Yes, Anchal, I will come to that point, right? Yes, 10 by 3 are rational, yes. So by looking at the decimal expansion, now we can figure out. Grisha, no doubts? Great. Now we will talk about the decimal expansion of irrational numbers. So when you see that the decimal expansion is non-repeating but non-recurring, right? So the decimal number continues endlessly and there is no repeating number or pattern in it, like numbers like pi. You saw that the number was endless after the decimal point, there was no pattern. And like this exponential value 2.718281, you can see that there is no pattern, right? And it is going endlessly. Yes. So if you come across such questions, there would be dot dot dot, right? Don't worry about it. Let's try out a question to get the better understanding. So which type of decimal expansion the following number has? Now look at this number. Tell me what kind of decimal expansion it has. Just by looking at the number now we can tell it. Yes? Yes, quickly. A, B, C or D. What should be the right answer? My God, you are taking too long to answer this question. Is it that difficult? Krisha D, Achal D, Prashansa says C, Ishika D, Rashmi D. Everyone is saying D. Let's check the answer. Yes, it's D. So Prashansa, I think maybe you have given this by mistake. So look at the decimal expansion after the number. It's 20, 200, 2000, 24 times 0. There is no pattern, right? It is non-terminating. You can see the dot, dot, dot. It is non-terminating, right? But it is non-repeating also, right? Non-terminating, non-recurring. So option D. Harshi says non-terminating, but you have to see that there is no pattern after the decimal point, right? Yes, that's what I thought, because I thought it's a very simple question. I hope Harshi it's clear to you that you have to see it is non-terminating, but after this it is non-repeating also. About irrational, sure. So in irrational numbers, you would see, first of all, you can see the dot, 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 right? That it is non-terminating. This is the first thing. It is non-terminating. Then we check the pattern in the digits. It is 20, 2000. So every time it is different. 20, 200, 2000, right? That means it is non-repeating also. There has to be a pattern like 20, 20, 20, 20, 200, 200, 200. Pattern is like this, right? All right. So this is clear to everyone, right? All right. So Simran says, wow, this is going really good. So please share some more concepts. Now he says that's enough for today. We have discussed a lot of concepts. So she is so excited that she will wait for the next session. So let's summarize what we have learned today. So we talked about the family of numbers, where we discussed about natural numbers, whole numbers, integers. We learned that in integers we have everything, right? Natural numbers, whole numbers and negative numbers, but no decimal numbers, no fractions. Then we talked about fractions. We learned about the another term as well, rational numbers, which include everything, which includes all the integers, right? Then we talked about irrational numbers, and we have learned about the decimal expansions of numbers as well. Just by looking at the decimal expansion, we can tell whether the number is rational or irrational. All right, a very interesting thing. Do you all know that April 22 every year is celebrated as the Earth Day, and more than 1 billion people actually celebrate this day. So what they do is, so basically why they are doing it? To make their planet a better place to live, right? So what they do is to make their planet better. What they would pick up the litter, right? Because you can see that they would plant trees, deforestation is there, so much pollution is there. So we should also take part in all these things, right? We should also take initiative. So what you can do is, whatever you do to make your planet a better place to live, you can share your photos, your videos or posters. There is a link given in the description below, a Google form link. You can fill that form and attach whatever you want to upload, right? Wow, that's amazing. Now comes the homework question. So which of the following is an irrational number? 4 options you can see. You can let us your answers in the comment section below after this session. So don't worry, we have got you covered. There would be many more sessions lined for you from every Monday to Friday to make you exam ready. Now let me give you a glimpse of the upcoming session. So our next session is on 26th April, that is Tuesday at 5 p.m. and it is going to be the NCERT Sprint 1 on number system. Yes. And there is a free trial classes link as well. Click on that link, get all your doubts clarified instantly during the class. And please like, share, subscribe so that you do not miss any new updates from us. So I'll see you soon. Take care. Thank you.